Welcome to my tutorial on how to make a basic 2D character controller. In this controller, we're going to make a character that can move left, right, jump, double jump, and dash. If you're looking for the code, it will be in a public repo below, or you can skip ahead to the various sections if you're looking for something in particular. One of the goals I have for this channel is to attempt to impart my education and therefore my thought process into the internet and hopefully into you. All right, let's start with setting up the scene. We're going to need a few things. First of all, make a brand new empty scene in a Unity project. I am using Unity 2022.3.47 F1. Ideally, you use that one, but you should be able to use any future Unities, and you can probably use quite a few past Unities before you'll run into issues. First things first, let's right-click, go to 2D, Sprite, let's do a square. All right, the square is white. Let's go ahead and make him yellow. Yeah, let's make him yellow. Good old piss yellow. Nothing ever goes wrong with him. I'm going to center him because I can. And then we're going to right click. We're going to create an empty and we're going to call it like 2D level. Then we're going to right click and we need a 2D object, another sprite, another square, and we're going to call this guy a platform. All right, this platform is going to need a box collider, so let's give it a box collider. And let's scoot him down a little bit and make him fat. Let's take a look at the game view. Ooh, that's very aggressively white. Let's go ahead and change his color to like a black. Hey, let's do like a gray, reddish gray. Yeah, that seems fine. All right, let's go ahead and let's center him. Crank him down to -2. Alrighty. Now that we have a platform, we're going to dupe the platform. So when duping something in Unity, you can actually hit Control-D. Now you do need to be careful because of Windows, which I assume most of you are using, Control-D actually means delete it. You'll just toss it right into your recycling bin. So make sure you're clicked on Unity, but Control-D is a more complete duplication than copy-pasting, although that is also probably viable here. So let's make 4 platforms. Let's scoot them into the rough positions. Well, let's have one up top, and we have one on the side, and we have this one over here. Let's shrink these 2 side guys so they're like not hanging off the edge weird like. All right, we almost have everything we need in here. So we've got our level platform, we got our 4 platforms. They all have box colliders, so that means when our character touches them, they won't fall through, but we need to finish our character. So let's rename it from square to yellow boy, or if you are in fact a girl, please feel free to call it yellow girl. We're going to add 2 components here. We need a box collider, 2D, and we need a Rigidbody, 2D. I cannot spell as per usual. And then the first thing we're going to do is we're going to freeze rotation to Z. If we don't do that, when we start to move around, we can actually catch one of the corners and start spinning. So linear and angular drag are both types of friction. So if you have values in those, your character will naturally slow down a little bit more. You can also add different physics items. If you can click on one of our platforms, you can see we can add a physics material here, and that will also cause the platform to impart friction on our little yellow boy. But probably the most important thing here, well, there's a bunch of important stuff, but the thing that is maybe most interesting is the mass. So we're mass of 1, which is basically nothing. If we put 100 here, we're going to move much more lethargically because it's difficult to get up to speed. And once we are at speed, we're going to be much more difficult to stop because a body in motion stays at motion unless acted upon by an outside force. And if you're a heavy boy, that outside force better be big. Something we aren't really going to deal with here, but you can see this collision detecting, discrete, continuous. Continuous is more expensive, but it's better. So maybe for your main character, you do use continuous, but for enemies, you probably just use discrete. And also interpolation basically is like, hey, am I going to run into something in the future? It looks a little bit ahead in the future, which is also expensive. And then it can better predict collisions and you would get outcomes that you would more likely to expect. So basically, if you're having collision issues, you should definitely take a look at like collision detection and interpolation. All right, let's go ahead and hit play, see what happens. We got no code in this game, but our character should fall to earth or ground. All right, now that the scene is set up, let's go ahead and give it a quick save. You should always be saving your work, but let's right click, create, C startup script, let's call it character controller, char controller, if I can spell, 2D, enter. And let's open that up. If you're very new to programming, you may look at this and be like, well, what does any of this mean? So right here, this is our class name. So if you ever change a class name, like in Unity, just right click, rename. This will be its old name and you also need to change this, but that's more advanced. And we have mono behavior. That means we are inheriting from mono behavior. We could also inherit from other things like IEnumerator source clip or something. It's currently mad at us because we have to implement its functions, but we aren't going to be really doing that. And then a quick look up here. So we're using the Unity engine, and these are grayed out because we're actually not using them right now. We could if we want to, and we may end up using them, but for now they're grayed out. All right, let's make a few variables. So serialized field, because it's pretty good practice to not make everything public. But if something isn't public, you will not be able to see it from another script. Movement direction, and then we got oh, how did that happen? And then we're gonna do, let's copy that. Speed. Alrighty, but you'll see some programmers have a private here. Private is actually inferred. There are 3 types of protection. There's public, no protection, protected, and private. Protected means the children of chart controller 2D can see and use that variable freely, but outside classes cannot. All right, let's make the speed 7? Sure. All right, and then what we're gonna do is we're gonna set movement direction equal to input dot GetAxis horizontal. And if you're wondering what that is, just give me a moment. All right, so this is actually move our character. In the update function, we set the move direction to the input axis horizontal. So we actually need fixed update. So we're gonna go fixed update. I'll have a video coming about that soon, but basically the fixed update is where most of your movement and all the physics calculations happen. So we're gonna, oh, I forgot one step. We need to go up here, another one of these, serialized field, but this time we need a Rigidbody 2D, and we're gonna name it Rigidbody, so we are real original. And set to nothing. So we can go over here, pop that down, pop, and then Rigidbody. All rigid bodies have a velocity, so velocity. And velocity is your vector of change. It's kind of like acceleration, but not. And then we're going to set it equal to a new vec2. And then movement direction. And then we're actually going to pass velocity its own y back. And then we're going to multiply movement direction by speed. All right, so what the heck did I just make? We're setting movement direction equal to the horizontal thing, which is basically a how hard or how long, really how long you're pressing A and D. And then in the fixed update, the physics step, we're setting the rigid body's velocity equal to a vector 2 of its movement direction, its direction vector, times its speed. And then we're passing its y back. So if it's height 5, if it has a velocity of 0 in its height department, it will have it will maintain a 0. All right, let's see how this works. Now, something we haven't done, click on your yellow boy or yellow girl, and then go over here into the new code we're making. You can see the character controller 2D. We need to drag that on over here. So just go drop it down. And now that we can see it, we can see our movement direction and our speed are here along with that Rigidbody 2D. Let's pass it its Rigidbody 2D and then hit save and let's run it. After the compilation, you should be able to hit A and D to slide off the platform into oblivion. Whee! It'd be real cool if you subscribed. What the heck is GetAxis horizontal? Well, I'm glad you asked. So we're going to pop over to Unity, File, Project Settings, Input Manager. I'm already there, but you can see horizontals right here. You can use the left, the right, and the A and D button to trigger it. What this does is basically the Input Manager saves you code complexity and code bloat. Let's take a look at what it would look like if we didn't have this. All right, here's an alternative way of doing it, really the old way before the input manager. So we're getting a key code A, and we're getting another key code D, to slide to the left and to slide to the right. We are doing the same thing down here, basically. This movement direction is just determining the direction our character is moving. But this code it has some disadvantages. It's far more basic. It's difficult to change the key code to allow players to customize which key does what, and it's much more bulky. And another thing, it does not use the fixed update to handle movement, which is always a downside. So we're going to get rid of it. But you would definitely play with some of this stuff and try it out if you like. You can kind of see its disadvantages and maybe envision some of its advantages. All right, now it's time to add jump. So serialized field, let's copy that. Want another float, let's call it jump strength. Let's make it 60. And then the float here is optional. But if you ever have a 0.4 for whatever reason, the float is not optional. See, it's mad at me. Boom. Then we're also going to add stuff down here. We need two more things. We need a transform, and we need a layer mask. And let's call this ground, and let's call this ground check. All right, if input dot get button down is equal to jump, capital, and ground check, which doesn't exist. I mean, check ground, which doesn't exist, is true. We want to rigid body dot add force transform dot up times our jump strength, and then force mode 2D dot impulse. All right, let's deal with the fact that check ground doesn't exist. So copy, paste, and then we want to return a Boolean. So we're going to do bool check ground. All right, and then we're going to go if physics 2D, because we're in 2D, dot overlap. Oh, can't spell. There you are. Ground check dot position. Let's have the circle check 0.25 float and look for the ground layer. And then if that returns true, we want to return true. And if not, let's return false. What the hell did I just do? So, one of those could misalign. All right, so input dot get button down jump. So that means when the button down is equal to jump, which will be spacebar for basically all of us, and if it's not spacebar, we will edit it to be spacebar, and ground check returns true, we're going to do this. That's pretty simple. We'll explain that in a moment. So what's ground check? So when ground check is called, we're going to make a physics circle at this position, the ground check position. Now, I'll show you what that is in a second. This is the circle's area, and this is what we're looking for. We're looking for a layer mask called ground. So let's bounce out to Unity for a moment. So we need to make a new layer. So we're going to click on our platforms. We're going to go down to tags. We're going to add tags. So let's add a tag called ground and save it. Then we're going to go to our platform, and you can actually hold shift and select the bottom platform. Now we have all of them selected. We go to layer, and then we go to ground. Boom. Now they're all the ground layer. The next thing we're going to do, we're going to click on our player. Ooh, it's pretty yellow. Right click, create an empty. So that means we have an empty game object in the direct center of the player. We don't want that. Let's scroll it down to his feet. A little bit there. Doesn't have to be exact, but you can see just a little bit. There's a small circle right there. We have an empty object basically at his toes. If we pop back over to this, we're making a circle at his toes that's this big, and we're looking for the ground. And if we find the ground, we're going to return true. All right, let's pop back up to Unity, click on Yellow Boy, and you can see right here, I dragged the 2D character controller up so it's easier to see. You can kind of grab it and move it around. You can see that our ground is set to nothing. So let's click on that and select ground. Then our ground check is not set to anything. So we can run over here, grab ground check, click and hold, and drag it over into that slot. Or you can hit over here and look for it this way. All right, now that we've got that all squared away, let's hit the play button. We can see, move left, right, and we can jump. Ooh, our jump's a little strong. All right, let's adjust that jump strength a little bit. But because we've exposed these things to the editor, click on Yellow Boy. Our jump strength's at 60. Let's drop that to like 30. That was pretty strong. And then we can hit play. See how it works out. All right, that seems a little better. Maybe a little strong. All right, let's go take a look at the code. So we can jump. Let's get rid of this print statement. No need to have it anymore. But we can't double jump. Right now, when we're jumping, we make sure that we are on the ground before we jump. But that doesn't work for double jumping. We're supposed to be in the air. So we need another check. Let's scroll to the top, make another serialized field. And this one's going to be a Boolean. Oh. And we're going to name it double jump. or double jumped, and it'll be true. So then let's go to our jump command. We're going to add a or operator or double jump. So what this is going to do, well, almost. 1 sec. We got to encapsulate. Got to toss brackets around check jump and double jump. So what this is going to do, all right, we have to press the jump button, spacebar, or ground check has to be true, or double jump has to be true. So let's go ahead and make double jump equals false. And in the ground check operator, we can go ahead and make double jump equals true if we are indeed back on the ground. But this has a bug in it. Let's go see what happens. Okay, this does have a bug in it, but I can't get it to reproduce. But I did when I was making this, so I don't know. So basically, let's talk about the logic of this. So we hit the jump button, ground check or double jump comes back as clean. They should both come back as clean when you're jumping. We add the force of the jump in an impulse, a kind of like a bound, a everything up at once, and then we make double jump false. Wait, but if we make double jump false here, how can we jump when we're off the ground? Well, ground check is called at the end of the update function. And if we're on the ground still, which we will probably still register on the ground, jump check or double jump is actually going to get returned to true. So logically speaking, we want to add an if statement here. And we want to go, hey, so if check ground is false, which we can just ask with an exclamation mark, then and only then should double jump be reporting as false. And then we don't have to worry about this actually running in time. It could potentially create a race condition. We can move left, right, we can jump, we can double jump, and we can skate around everything. We're pretty floaty in this character controller. There's not a lot of, it is a basic character controller. But if you'd like us to be less floaty, just click on your yellow boy or yellow girl and then adjust your mass and potentially the gravity scale. The gravity scale will drag us down faster and the mass will make us harder to move. But when you do that, you are going to have to adjust the jump strength to be higher because the jump strength is adding a force instead of altering its velocity. Adding a force also alters its velocity, but it's a little bit longer of a way to get there. So feel free to play with that and get that how you want, but we're going to move on to dash. Before we get started with dash, I'm just going to toss this in here. It is another way to do the jump command. Just like we have the velocity down here, we'd be adding the velocity in a upwards direction jump strength. Now we should be multiplying that times transform of. But basically, instead of adding a force, we'd be altering its velocity. Let's add some more variables. So we are going to need dash strength. Let's make it 30 again. We are going to need 2 booleans. Can dash. That'll be true. Let's make those one false. And is dashing. Oh. Then in the update function, if input.getButtonDown is dash and can dash is true. This is where some of our choices are going to catch up with us. So in the fixed update, we alter our velocity by adding the movement direction times the speed. This happens once per frame. And you can see we also keep our y, whatever our y is. That's why jump works. We're actually adding a bunch of upwards force in the y, but we just carry that over. But we clear out the x force. So anything that we add here that changes the x force will get changed back to 0 or whatever the movement direction is. So we're going to do a couple of things. The first thing is we're going to do an enumerator. So we're going to do start, coroutine, and let's call it dash. Oh. Now, we don't have a coroutine called dash, so let's go and make one. Enumerator, not enumeratable, but enumerator. Let's call it dash. Oh my gosh, can't spell. Then, all right, let's go. Let's make it not mad at us. Yield, return, wait 4 seconds. Let's do like 0.5f. Now that enumerator is done, also I forgot a new here, we need to can dash is false. Oh my gosh. Is dashing equals true. And then we're going to go ahead and set the rigid body gravity scale equal to 0. So this dash is going to basically stop your movement in really any direction and scoot you either into the left direction or the right direction. All right, rigid body dot velocity equals new vector 2, and then direction. This doesn't exist yet, but it will soon. If I can spell it. We'll fix that later. Times dash strength 0f. Let's return the gravity scale to 1. That's our standard. This isn't the best practice. We're just hard coding this in, but you could go ahead and set this to some sort of float or whatever and be like, oh, rigid body gravity scale equals temporary int gravity scale, and just pass it back in if you change the numbers. Or you could expose it via a serialized variable up above. Really dealer's choice. And then we're going to write is dashing is now false, and can dash is now true. All right, so what are we doing here? We got a rigid body, we're adding a velocity to it, and this is the direction vector, sometimes called the normalized vector by math people. So we're multiplying our direction vector by the dash strength, so we'll dash in the correct direction, and we're passing in a y of 0. You could also pass in, like we're doing up here, just keep your y velocity if you'd like. That could make the game a little bit more easy, or more interesting. That's really kind of up to a designer's eye. So let's go ahead and make this direction thing. So copy, paste, and we want to return an int. So direction. And this is going to be pretty simple. We're going to do if movement direction is greater than 0, we're going to return a 1. And then if, and remember, anything after return isn't actually ran. So return is stop here. If the opposite is true, we're going to return a -1. And else we're going to return 0. So what does this mean? This means that if we're moving left, we're going to return 1. If we're moving right, we're going to return a -1. And if we're not moving at all, we're going to return a 0. So that means we cannot dash if we return a 0. That is a choice we have made. Now, if you wish to not make that choice, you have to come up with a different way of determining the direction. You could add some sort of flipping mechanic that'll flip your script or your sprite back and forth based on which way you're going, and then you could mount a game object to it and then determine the distance, like an empty game variable, like we're doing the ground check. You could determine the distance between the empty game object, called from the front to the center, and if it's positive or negative, that would be which direction you should choose. You know how I said that up here this would get clear? Yeah, this isn't done. Oh, this isn't done either. So in fixed update, we need to go if is dashing is true. So this is that's what that is. You don't need to have equals true. That's actually just unnecessary in C#. We want to return nothing. So that means if fixed update runs, but dashing is true, we don't do anything here. Let's try it out. We need to make sure the computer knows what dash is. So we're going to jump up here, hit edit, project settings, input manager. Stop that. You need to go to one of these that you're not using, like I have, and type in dash. And then you need to come down here and make the positive button F. We don't really care about any of the other buttons. They're not going to do anything. It should look similar to jump, which is right. So move left, right, jump, double jump, and dash. Ooh, our dash is a little strong, and we are in the ether now. So let's reduce that a little bit. Go ahead and drop that to 10. Play again. And let's jump around. So this took me about probably 4 hours. The dash stumped me because I can't remember things, apparently. Oh, there's also another bug we need to fix. If you jump into one of these walls and you'll actually just stick there, probably don't want that. So we can go over here. We go to Assets, right-click, Create, 2D, And then physics material 2D. Let's make it kind of slippery. We're at 0.4. Let's drop it to 0.2. And then we're just going to paint everything with it. So hover over here, hold shift, click platform 3, drag this over. And then we're also going to give it to the player over here, give it to their Rigidbody and their 2D collider. If we hit play, we shouldn't be able to stick to anything anymore. But this may be how you could implement a wall hugging mechanic, but well, you can still stick a little bit. Let's make it a little bit slipperier, make it 0.1. But basically, you can keep lowering that all the way to 0 until you get the amount of slip that you want, or lack thereof. Oh, we might have to move ours to 0 since we have like no mass. Let's just make it 0. Come on. All right, you can see we slipped right off into oblivion. We can dash, we can jump, we can double jump, and we can scoot around. And, I know plenty of people talk about getting stuck in tutorial hell and, how do I do any of this for myself? Well, I want to challenge you with something. I brought up the direction as a possible fix, since if I hit F now, nothing happens. You can't actually dash when you hit F if you're not, going somewhere. You could adjust that so it remembers like the last direction you were looking, like I was talking about, like flipping the sprite back and forth. Or, you could implement a couple of levels. It's not that difficult to slap down an empty game object, make it like a portal thing, toss like a blue circle over it, and then have it call and load a brand new level that you make, and then you can mess around and play with that. Slowly building out your repertoire to be able to do more and more things allows you to do these things quicker. I remember a time where what I just did in like 3 hours, mostly because I was bad at it, it might take like a week, an actual like 12 to 16 hours, and I'd be Googling things and looking things up. And mostly I was just doing that to make sure I was giving everybody the best information possible. So if you like this video and you made it this far, a subscription would be great. This content isn't exactly the easiest to make, and I hope it helped.